Your test on Friday does have quite a bit of type 1 and type 2 errors on it. You will have to do a full hypothesis test from beginning to end. I will not give you any hints on the steps, kind of like I did on the quiz where I broke it down and give me the hypotheses, give me the standard deviation of I don't break it down at all. I just say perform the test. So you're going to need to study the steps to that, okay, and what you need to do and how you need to do it. So when I give you your quizzes back today, at the end of class, we can talk a little bit about that second question on the back of the quiz. I think that provided some issues for a lot of us, okay? So let's spend a little bit of time talking more about type 1 and type 2 errors. A lot of this you should have read last night, but hopefully we'll kind of solidify some thoughts. Now, I really like this graphic from the book, except for one little piece. The piece of the graphic that I'm not a fan of is the word retain the null hypothesis, because we never really retain anything. We either reject it or we fail to reject it, right? So look, can we do me a favor and just change this wording to be fail to reject? Because we either reject it or we don't, okay? And I will tell you that in any of my AP trainings that I've done for statistics, they are very particular about those wordings. And I know that AP Bio, if you are in AP Bio, they have a different wording than AP Stats. But I really need you to be pretty specific about this, because you will get deducted points for it. Okay? All right, so I like this graphic because there's really two different things going on in any kind of given hypothesis test. There's the truth, what's really going on, which sometimes we know and sometimes we don't know. Like if we wanted to figure out the proportion of whales in the Atlantic Ocean, we don't really know what those are, right? So we don't really know what the truth is. But then based on a hypothesis test, we have a decision that can be made, okay? So the truth is either that the null is true or it's not true. That makes sense. And then the decision that I make based on my hypothesis test is I either reject it or I fail to reject it. Okay, so based on this graphic, we're able to see where an error would come into play. In the purplish blue sections, there's no error. I can reject a false null. That's the goal. If the null is false, then we should reject it, right? That means we've done something correct. Rejecting a false null is good, okay? Failing to reject a true null. If the null hypothesis is true and I get a kind of a big p-value, I can't reject it, can I? So failing to reject a true null hypothesis is also not an error. The errors come into play in the other things where I can reject something that was true or I don't reject something that was false. And those are where you get your type 1 and your type 2 errors. And we talked last class about the context of those.
So you know that you made type 1 and type 2 errors, you have to know for sure that HO is true.
You would have to know that information. And we're going to talk a little bit about how to calculate those probabilities. It's more, we're going to look at one in a minute. Maybe that'll solidify that for you, your thought process, so to hold on to that thought. But you're right. We often don't know the truth, do we? Okay? We just can base our information on what we think is true. Okay, good. All right, so being able to find the probability of these type 1 and type 2 errors are sometimes things that are asked. The probability of a type 1 error is easy. It's just equal to the alpha level. So oftentimes we have an alpha of 0.05, okay, a confidence level of 95%, right? I'm sorry, 95% confidence interval, a confidence level, or alpha, of 0.05. So a type 1 error, you can put this in your little box in your chart if you want. The probability of a type 1 error is just alpha, okay? Because a type 1 error occurs if we reject the null hypothesis when it's true. When do we reject the null? Well, we reject the null when the p-value is less than alpha. So alpha would be the probability, the likelihood that we would do that. Okay? So type 1 error is just the probability that you would reject the null. A type 2 error, and again, we never accept anything. We fail to reject. That's equal to something called beta. Okay, the probability of a type 2 error, just from a notational standpoint, we call it beta. Okay, like a B, it's the Greek letter beta. Okay, now finding the type, now, by the way, these do not add to be 1. Okay, what actually are complements of each other are these two things. Okay, rejecting a false null and failing to reject a false null are complements of one another. So if we're ever given a probability that I could reject a false null, I would be able to find the probability of a type 2 error because I could just subtract it from 1. Okay? That's important. Because finding the probability of a type 2 error, there's really only 2 ways to do it. One is if I'm given this information. If I'm given this information, I can just subtract it from 1, okay? And we'll look at another situation of how to find it in just a minute. The probability of a type 1 error is equal to the alpha level. We know that. That's great. Probability of a type 2 error, a little bit more difficult to kind of nail. Type 1 and type 2 errors, the probabilities are kind of related, but they're not complements of each other. Okay? As one goes up, one does go down, but they're not necessarily complements. Yes?
If we were ever asked the probability of failing to reject something that's true, would that be 1 minus alpha?
No, that's a good question. Let me think about that. That's actually a really good question. You know, hang on. Well, if I don't know the answer, I'm not going to ask you that question, right? Let me think about that, okay, and get back to you. We have Flex together tomorrow, right? So can I answer that during Flex? I need to think about your question because it's a good one. I don't think I've ever asked that because the type 1 error, I don't know. Let me think about it, right? And I'll let you know. It's a great question. All right, I want to stick on type 2 errors for a minute, though. Can we do that? Come back to that thought? Okay. So the power of the test, which is one of the questions it asked you on your homework, is actually when you reject a false null. Okay? That's the power. 1 minus beta is the power of the test. So just like if we were given the probability of a type 2 error, I could calculate the power of the test by just subtracting from 1. They are complements. Now, the strength of the test or the power of the test comes from what we want to do. We want to reject the null. We want to say it's wrong. We're trying to prove something else is happening. We think there's not enough orange M&Ms in my bag, right? We think that their claim is incorrect. So we're hoping to be able to reject the null. That's the goal. So that's why that's the power of the test, because that's a correct decision. Okay? Okay, so far. So just a definition of what is the power of the test. It's just rejecting a false null, and it's bound by 1 minus the beta. It's the complement, and you subtract it from 1. Absolutely. In other words, this plus this should add to be 1. Good. All right, so here's kind of like the relationship between alpha and beta. Remember, alpha is the probability of a type 1 error, and beta is the probability of a type 2 error. So if we know that the null hypothesis is true, this is kind of a graphic from the textbook again. You can kind of, let's talk our way through it. And then we have a situation where if we reject a false null, right? I'm sorry, we fail to reject a false null. I said that wrong. If we reject a true null, sorry, that's an error, which would be this red section, okay? If we fail to reject I mean, if we don't reject one that wasn't true, that's your beta. That's your power. So we have two different situations. They're not complements of each other because one situation is where the hypothesis is true and the other one is where it's not true. Okay? So they're kind of different situations. But you can kind of imagine this imaginary kind of this line here that if the power increase, or sorry, if the power increased, what happens to alpha? Wouldn't it also increase? Okay? And if we go the other direction, so there is a relationship between them, whereas one goes up, the other goes down. However, they're not complements. Okay? They don't add to be one. The only thing that adds to be one is this and this. So I think based on this graphic, Charles, I think you're right. They are complements of each other as well, just based on the graphic alone. Okay? Good. Okay? Excellent. So here is a problem I would write down in my notes if I were you, because it's something similar on your test. Okay? So here is an instance where we could calculate the probability of a type 2 error. And I was trying to think of a situation, and I came up with a trial. Okay? In a trial, there are two situations. The actual truth of what happened, which we may never actually ever know because no one was at the murder scene, right? And then what the jury said happened. So I kind of created, like let's say there were some cases that I went and I observed and I surveyed some people and I said the number of innocent victims, what really happened, was 120. And there were 25 actually that's not true. There were 124 innocent victims, and there were 135 guilty victims. Okay? There were 135 people that actually did it. They pulled the trigger. Okay? The verdict is something that's a decision that's been made. Would you agree? That's my decision, or that's the jury's decision. Kind of like a hypothesis test. You make a decision whether you reject or fail to reject a null. Okay? So, they're either innocent or guilty, and then the jury decides whether they're innocent or guilty. There could be some errors along the way. Would you agree? Okay? There are people that are falsely accused is not the right word, but falsely convicted, thank you. Falsely convicted. There are some people that get off. Think of OJ, right? We all go to OJ. Right, so we okay with the scenario? Okay, what I've created here, they're either innocent or guilty, and then we decide that they're innocent or guilty. All right. So what is the probability of a type 2 error in this situation? Now, we have to have a null and alternative hypothesis, really, don't we? Because we're rejecting a false null and rejecting a false or true null and that kind of stuff. So I created a null and alternative. The suspect is innocent or the suspect is guilty. So I'm going to pause the recording for a minute, and I really want you to think about the probabilities of a type 2 error. First of all, what is a type 2 error in this case? Okay? And then how can I use the numbers here to be able to come up with a probability? Okay? So I'm going to pause the recording. I want you to think about this question. So we have to remember the wording of what a type 2 error is. Okay? So a type 2 error, and I even wrote it on my little notes over here for myself, is when I fail to reject a null hypothesis when it's false. I'll say when it's actually false. Okay? Now, Judith said it differently when I asked her, and I kind of liked her response. Okay? What did you say it was? A false positive. Okay? Because it's actually not happening, but we say it is, right? So it's like a false positive reading on a test, like a I don't know, drug test or something like that. Okay? So another way to think about it, which I really like that wording. All right, so we have a null here. Our null says that she's innocent, okay? But the null is actually false, so what's actually happening is that she's not innocent, but she's actually guilty. So we're in this column over here. Would you agree? Okay? Now it says that we fail to reject it, which means that we actually say she's innocent. So this is the number of people that get those false positives. Type 2 is a false positive. We reject the null when it's false. So in this case, okay, they're actually guilty, but we say they're innocent. So let's do it. Let's talk about it in terms of an actual drug test. Okay. So what's happening in a drug test? Let's make sure we understand what. So we actually have the disease, or we actually don't have the disease. Okay. And then the other thing that could happen would be that the test is positive or the test is negative. Would you agree? So this is actually what the test says, and this is what actually is going on. All right, so where would a false positive lie? The test says you're positive, but you don't have it. That's the type 2 error. Now, the location of the box might be different than the location in the original thing I wrote. We okay? You're not okay, Isaiah.
Well, like when I read it, it said that type 1 is false positive and type 2 is false negative. So I kind of
All right, so maybe I'm thinking of it wrong. So let's make sure that we're okay. So the test says positive and you don't have it. So let's make sure. So the null would be that you don't have a disease. Sometimes I have to talk it out myself, okay? So you have no disease. The alternative would be that you have the disease, right? And so a type 2 error is when you fail to reject a false null. So we're going to fail to reject this, which means we say they don't have the disease. So we say they don't have the disease. We say no disease, but they do. So that is a false negative. You're exactly right. Okay, so that would be a false negative. Thank you very much, Isaiah. Sometimes I have to write it out. Okay, so false negative would be a type 2 error. So let's make sure what a type 1 error is. A type 1 error is when I do what? I reject, but it's true, okay? So a type 1 would be I reject this, which means I say that they have the disease when they actually don't, right? Therefore, that would be a false positive, okay? Right, the chart, it's the order of the chart that was messing me up too, actually, quite frankly. Sometimes you got to write it out. Which one, just from a context point of view, when we're talking about a false negative or a false positive, when we're talking about a disease, which is probably worse? Probably a false negative, because you're not going to get the treatment that you need for the, like, let's say it's cancer or something. You could die from the disease and not have treatment. A false positive, well, that just means that you're going to get treatment for something you don't have, which could be bad too, depending what the treatment is, I guess. Cut your leg off. Oh, sorry. Exactly. Right. Okay. But thank you for letting me hashing that out. That was good. All right. So back to this problem. Do we still agree that 25 is the right number that we're dealing with? Okay. So 25, we're looking for a probability. So 25 out of what is the key? Well, it's out of everybody. Okay. So you're going to add them all up. That's where the other number came from. Okay. So we're going to add 120, 4, 25, and 110. What'd you get when you did that? Which is 259, not 159, right? So 25 divided by 259, really? Fat fingers. It's about 9.5, about 10% or so, approximately. Okay? So the probability of a type 2 error in this case would be about 0.0965. Okay? oftentimes we don't know the truth, right? You can't handle the truth, or whatever, that movie is, right? So oftentimes we just don't really know what the truth is. So finding the probability of a type 2 error in real life, oftentimes you just can't do, because you just don't know what the truth is, okay? But in this particular kind of a situation, I just tried to create one that you would be able to put numbers to and you could find it. Okay? So there's two ways if you're ever asked to find the probability of a type 2 error. The first one is it's the power of the test subtracted from 1, right? And the second would be if you're given a situation where you're told what the truth actually is. Okay? Those are the only two ways you could find it. Fair enough? Okay. Let's see. Okay. So these three things are kind of backs up what I just basically said. Sometimes we can't actually calculate a power unless we know the probability of a type 2 error. But there are three things that will increase the power of the test. These are probably things you should write down. Okay? So isn't the power of the test what we want to happen? It's when we reject a false null. Okay? That's the power of the test. That's the goal. We want to reject it. We want to prove them wrong. So we want to try to increase the strength of that test as much as possible. Okay? So what are the three things that could make that happen? And here they are. Okay? So the larger the size of the discrepancy between the hypothesized value and the true value, so what we think it is and what it actually is, the larger the spread is between those two things, the higher the power of the test. And that makes sense. If the claim is just so far off from the truth, 99% of the M&Ms in the bag are orange, okay, we can probably reject that null, right? Because that hypothesized value ain't nowhere close to the truth, okay? So that's really what that's saying. If the claim is just so far out there, then that's going to strengthen the test, okay? Because the likelihood of us rejecting that's pretty strong. Would you agree? Okay. Number 2, the larger the significance level. Now remind me what that is again? Alpha, right. So the larger the alpha, okay, often it's 0.05, but sometimes it's 0.1. Remember 0.1, a significance level of 0.1 would correspond to a 90% confidence interval, okay? The larger the significance level, well, if our significance level is larger, aren't we comparing our probability to that, and don't we want that to happen? Our p-value, right? So if this number is bigger, then aren't we have a higher likelihood of rejecting the null? Because our p-value can be even higher. We can have a p-value of 0.7 if alpha is 0.07 if alpha is 0.1, right? But not if alpha is 0.05. So the larger this alpha is, the higher likelihood is that we will reject that null as well. Okay. And then the third thing that could increase the power of the test, which is what we want to do, is increasing the sample size. It seems like increasing the sample size does a lot, doesn't it? Okay? What else does increasing the sample size do for us? Okay? It's making our margin of error smaller, which is what we want to do. We want to shrink our confidence interval. We don't want to have a really big wide interval that doesn't really, it's not meaningful. We want to have it, we want to actually truly capture that proportion. Good. That is something else that the sample size, increasing it, would do. We want it to be big enough, but not too big. Can't be more than 10%. That doesn't make it valid. Okay, so these are three things that could increase the power. You will see that on your test as well. Looks like a multiple choice question, doesn't it? Which one would not increase the power? Okay. All right, test is next class. Okay? And then we're done. I'm done. We're done. Woohoo! That's all the new material. Okay, that's it. So I'd like to give you back your quizzes today, and let's look at them and go over whatever questions you have on them and whatever other questions you want to ask between now and then. Okay? So let me get those out for you. It's on here. So when I made the test, the free response is very similar to your quiz. The only thing would be maybe putting type 1 and type 2 errors in context. Okay? There might be a couple of those on your free response part. So it's very similar to your quiz I just handed back, except for some type 1, type 2 error contextual stuff in there. Maybe a little bit on the power of the test, something like that, but nothing too hard. The multiple choice questions, in my opinion, are the ones that are a little bit more difficult on this particular test. Not because I made them difficult, but it's the wording, I think, and being able to pick out. There are a couple of questions where it would have like Roman numeral 1, something's true, Roman numeral 2, something, Roman numeral 3, and so that's kind of like the question. It gives you this information, and then the answers would be like, well, 1's correct. Well, 1 and 2 are correct. 1 and 3 are correct. Okay, none are correct. All are correct. You know, that kind of thing. So there are a couple of those on there. Now, AP has tended to kind of get away from that questioning format. It used to be very heavily in the curriculum, like almost all the multiple choice questions were like that, which is why there still are a couple on, tests here and there that I give. They're not as heavily written that way anymore, okay? But on this particular test, I know there's at least 2 that are written that way, okay? So you're going to have to kind of really understand what parts 1, 2, and 3 are saying, and can I just fully eliminate 1 altogether, okay? Want to go over the quiz, the back part of the quiz? I think that would be a good idea. Let me check on Devin and Hunter and see where they are so I can talk and project. So we're going to have to whisper because they're taking the quiz out there. And I don't want to give them any hints. Well, they can't see, but Charles will look. They can't see, but I'm afraid they can hear. Okay? So I'm just going to kind of write it up here. Fair enough? Well, I'll try, but I have to whisper. Okay, shh. Ready? All right, turn the volume up if you're listening. Okay, here we go. So on the back, okay. Any questions on the front first, though, before we get to the back? Anything that you weren't sure about? Tanner? Shh. Okay, so, shh. All right, in number 1, when you have a confidence interval, okay, the confidence interval was this. Okay, remember this is P cap, Z star, and is it standard error? Okay, so what's the margin of error? So when I multiply those together, I get 0.028. Okay, which is what you add or subtract to either side. Okay? That's the formula. I probably prefer you to write the actual answer, which was this. Okay? But work, and on the test, I want the work shown and then the answer. Okay? So I really want both of these things if I ask you for a confidence interval. Because the calculator spits this out. Do you agree? So that's fine, but I can't give you full credit unless you show me the meaning behind where it came from. Okay? Fair enough? I won't be here Friday to remind you, but show work. How do I get Z star? Okay. I think it's 95% confidence interval here. That means the middle number, the middle is 95%. Each tail is 2.5%. Right? The Z star is the right-hand margin here. So you're going to do inverse norm, negative E99 to 1.9, I'm sorry, what am I doing? Inverse norm, you put the percentage in, right? 0.975. And then in this case, it's 1.96. Question? No? So that's a question like on number 3, where you had a weird one, right? It was 92%. So what would change in this problem, Lena? This would be a 92, and therefore you have 8% left, so each of these would be 0.04. So you would add 92 and 0.04, so it'd be 0.96 here. Okay, which means 1.75 is the z-star. Okay? Can I what? The sentence. Oh, you mean the interpretation? Okay. Of the confidence interval? Okay. The confidence, I'm going to write it. So that, what I've written in green there, is the interpretation of the confidence interval, which, as you can imagine, I will probably ask you to do on your test as well. Okay? Now, that is not, that's on the back, sorry. It's not the p-value interpretation, but we'll talk about that in a minute. All right. Let's flip it over. Let's look at the back. Okay. I was actually quite pleased at how many people got the whole first page right. Okay, there wasn't as many points taken off on the front as there were on the back. But let's look at the back. All right. So we've already talked about number 3, right? I'm going to do it again. Let's look at number 4. So the problem with number 4 is that the 55% was given first, okay? And 55% is not the P. It's actually a result of the study. So that's your P hat, okay? And so many of us mess that up, because it's the first time, I think, where you read a question and the first number that came wasn't P, right? So you really have to look at the information that's given to you in the context and make sure. It does say that's a Gallup poll result, isn't it? Let's keep reading. So it says we want evidence that at least half of the adults get sleep. So half, 50%, 0.5, is what the claim is. Okay? So what do you have to remember? That your hypotheses are always written in terms of what? P or P hat? P. So we think that half of adults get sleep, at least half, right? So half of adults, that's what the context switch should say. Half of the U.S. adults get enough sleep. Here we think maybe there's more than half. Okay? More than half of adults get enough sleep. Okay? That's what we're trying to test. Obviously, make sure you write the context next to each of those hypotheses, because I counted for each. Okay? I didn't write that, but you will. Right? All right. What didn't I have you do on this problem that you should have? The conditions. It said in the problem there's no need to, but on your test, when it says conduct the hypothesis test, you will check the conditions, right? Don't forget that step. You didn't require it here, but I need you to on the one on your test. Okay? right, so let's assume we've checked the conditions. Now the conditions have been met, so we'll find the standard deviation. We have P. Oh, hang on a minute. All right, I actually did my standard deviation different. I used P hat in it instead of error on Miss Meckert's part. Does that affect the problem? Let's see. Okay, let's do it this way and let's see if it's different than what I do here. Let's see how much that affects it. Let's see. So okay, it doesn't affect it. Yeah, I mean it's not that different. So it's still 0.0223. I think it was 2216. It still was 222. It was so close. It's close enough that it's not going to really affect too much. If you're given a P, you use it. You really only use the standard error in a confidence interval because you don't have P. Yes? Are we all right? You were stabbing the elf on the board. I was like, what are you doing? All right. So the other thing we have to do is this. You put it on you can put it on my desk for me, honey. All right, do we still get the same? Let's see. So 2.25. I got 2.26, sort of. We're okay. Okay, so that's that. And then I was looking for the curve. 0.5, 0.55. We're going to shade to the right. You okay so far? Remember your P always goes in the middle, your claim, and then your P hat, whatever your poll or your data, your statistic, goes around that somewhere. So the p-value, it is one-tailed test. Get that as your p-value, hopefully? Something close to it, okay? And so it says to interpret this value, okay? To interpret a p-value, the p-value is the probability or likelihood that our sample happened by chance. So the likelihood that our sample happened by chance is about 1.2%. Pretty small. What'd you do, babe?
Like, what I typed into the calculator was like way different, but we got the same result.
What'd you type in?
But it came out.
Well, I don't know what you typed in. Maybe you got the p-value from doing the test in the calculator. That's possible. No, I don't know how to answer it if I don't know what you typed in. You know what I mean? If you can find out, did you write it down? Let me see. Oh, you did. Okay, it's because your the tail probability on the other side is it's because of the it's because 0.5 and 0.55 are so close. If you have them backwards and you flip them, you're going to get a close probability. But your graph was incorrect because of the placement of the 0.5 and the 5. Okay, so that's the same thing. So I had to take off points because of based on your graph what you typed in. Does that make sense? Okay. All right. Still talking quietly. I apologize if you're listening to this. Who should be listening to this? Who's not here? Stephanie should be listening. Zachary should be listening. Brian should be listening. Shout out. Okay. All right, so we've interpreted our p-value. I can talk normal now. Woo, woo. All right, go ahead, Devin. Put that on my desk. I know. I'm just saying. I was just talking quiet. Okay. So we have to state our conclusion in sentence form and in the context of our problem here. So we aren't given an alpha to compare it to, but we will use 0.05. So we're looking and hoping that this happens. It actually does. Okay, so based on the fact that our p-value is less than our alpha, are we going to reject or fail to reject? What are we doing? Rejecting that bad boy, okay? So we're going to reject the null. You need to state that and actually tell me what you're doing and then put it in context. So in context would mean we have evidence to suggest this is our evidence, this hypothesis test that we created here or that we conducted. So we have evidence to suggest that more than half of adults get enough sleep. Okay? Good enough? Remember what I also said a couple class periods ago, that we could also compare our z to our what? The z star, and look at that as well. Okay? Okay. So, number 5. A lot of y'all left number 5 blank. We did a problem exactly like number 5. We actually did a problem exactly like the extra credit in class. Okay? Yes, love. Okay. It should be 752 is the answer. Ooh, let's look at it. Okay? So it says that we have a margin of error of 0.3 or less. Okay? So we're going to look here. So we're going to have our margin of error. We do have a 90% confidence level, which means our z star is 1.645. A couple of you wrote 1.65 or 1.64, which if you round that any differently, it will affect your answer. So I had to take off points for that, okay? But I tried to look at what you were doing and your work to give a good conclusion. So I tried to give you as many points as I could because your process was fine, but you just really can't round. At 90%, we really do use 1.645, okay? So try not to round that too much. And then here, we're trying to find n. What do I do for my p hat, q hat? 0.5, 0.5, because that's, you know, what we don't know. And then you would solve this. Okay, divide by 1.645 first, square both sides, etc. I got this when I did my capturing and I didn't round anything. And then you know you have to round up. Okay? Yes. Based on the problem above? Okay. So as long as your process is right, you get most credit. Okay, so I'll just look, and if that was the error, then that's the error. But when you're looking at this, you always put 0.5, 0.5, okay? Because you don't want to give any one thing an advantage. All right, extra credit, are you interested? Okay, it is 92%. Okay, so let's look. So here we have, again, a margin of error of 3%. We are looking at what confidence level, so I don't know my z star. We are told that the rating was 62%, so we'll have to, I don't even know what just happened. Okay, so I'm going to go ahead and plug in the information. We have 800 people. And so we're solving for z star, basically. We're going to simplify what's under the radical, and then we'll divide both sides by that number, and that will give me a z star. Okay, I got a z star of 1.748. How do I go from a z star to a confidence level? Well, we know that the confidence level is somewhere in the middle. I have 1.748 as my z star. We know based on the symmetry of a normal curve that we should have negative 1.748 over here. And then you just calculate the probability in the middle. So I'm just going to do normal CDF from the left hand to the right hand. And because it's a z value, our mean is 0 and our standard deviation is 1. So if you just type in normal CDF from negative 1.748 to positive 1.748, a mean of 0, a standard deviation of 1, because they're z-scores, right? We get about 92% confidence. Really? Okay. I think we did one almost exactly like that in class. All right. So I'm going to assign problems from the book that are comprehensive. I didn't really assign a whole lot of problems from type 1, type 2 errors, but they're on the test. So what I'd like to do is assign some of those that are even, so you can check your answer in the back of the book. Oh, sorry, odds. Thank you. Odds are in the back of the book, and that way you can at least have some practice with those. Okay. So let's go ahead and do that. Again, chapter 22 will not be on there. Original plan was for it to be, but just couldn't do it. I think you seem to be okay with that. So let me pick out some odds. I think I'm going to do 19 and 21. Let me just make sure those make sense. In chapter 21. Yep. Okay. So yes, honey. I'll try my best. Okay, because I wrote the test during my 5th block period today. It is fresh in my head, but
I mean, it's okay if it's not.
yeah, it's not going to be totally. But yes. So in chapter 20, I want you to do problems 19 and 21. Okay. I might have you do something with the power too. Oh, it is. So 19 has that. All right. So that seems reasonable. Okay, to do those two. You've already done some context stuff with the. Huh? 21. Thank you. Those should be for type 1, type 2 error, power of test questions, okay? Plus the notes we did today. Remember what 3 things increase the power of a test. You know how a power of a test and the probability of a type 2 error are complements, that all those things are going to be tested as well. All right, then I want us to jump to the end of the unit review. The review of part 4. So let's figure out what we can assign there. Dun, dun, dun. Okay. So you're going to have to do okay. I'm going to have you do, so the review starts on page 513, okay? And it's this review in the book that they're giving us do include the 2 proportion z-test, which we don't know how to do yet, so I just want to assign those types of problems, okay? But I think number 7 is a good problem to look at. Just double check. Nah. Okay. I only want to assign odds, right? Okay. Let's go ahead and do number 9. I want you to calculate a, here we go. Oh, 10 is good. What? Don't do 7. Nah. Okay. Do 13. Two proportions. 21. $27. 29. We'll we'll do a 37. 37 is another type 2 error question. Okay? So, the mixture of confidence interval questions, hypothesis test questions, and type 1, type 2 error. But that's really everything that's on there. Okay? Do you feel okay about it? They're all odd problems, so they should. I will be on email. So, and I will be here. Do I have a meeting tomorrow? I'm trying to think. After school. We have flex. We have flex together, right? Tomorrow? So bring questions you have for during flex tomorrow, and we'll answer them. So please start your homework tonight, okay? And then we'll go over whatever flex questions you have during flex. Fair enough? Okay.
One thing I forgot how to do.
Yeah, right?
I was trying to